Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 1.5, in which we ask the essential question, how can you use a formula for one measurement to write a formula for a different measurement? We're going to rewrite these equations, rewrite these formulas, and let's get started. Okay, so we're going to start off. We want to say, it says solve the literal equation. When you think of literal equation, you can think of it as a formula, all right? We've already dealt with one formula, one literal equation a lot, and that, of course, is the distance equals rate times time. Okay, that's a formula for distance and rate and time, actually. So we want to solve this 3y plus 4x equals 9. We want to solve it for y. Well, we're going to follow the same steps as we would solving any equation that has all numbers in it and one variable to solve this as if this x were 4x were a number, right? We have to treat it like it's a number because we can only deal with one variable at a time. So we're solving for y, and we want to isolate the y. We want to get y by itself. Okay, so the first thing I need to do here is subtract 4x from both sides. So that's going to leave me 3y on the left side equal to, and I'm going to write it in this order, negative 4x plus 9. Because typically we put the variables first and any plain numbers go last. Okay, so now what? I want to, again, isolate the y, so I have to divide both sides by 3. So 3 divided by 3 is 1, and 1y equals y. So y equals, now over here, can I do any of this math? No, I can't. I can't really reduce, I can't reduce the 9 by the 3 because I really can't reduce 4 by the 3. So that's basically going to be our final answer there, if you want to call it an answer. Y equals negative 4x plus 9 all over 3. Solve for y. Okay, let's try this easy example. Y equals 3x plus 5xz. We're solving this for x. So we want to get the x by itself on one side. Okay, so what we can do here is, since both of these terms on the right side have x in it, I can do that reverse distributive property thing. We saw that a little bit earlier, so I can factor the x out, giving me x, and that leaves 3 plus 5z. Right. Okay, so I've turned this into a multiplication statement, because now, since x is by itself out here, I can divide out the 3 plus 5z on both sides. And that leaves me x on the right, and on the left I've got y over, and I'm going to reverse this here, 5z plus 3, because I want to put that constant last and the variable first. That's our kind of our standard way we do it in algebra. Okay, that's that one. That one's a little more difficult because of this factoring thing here. Let's take a look at what's next. I'm not really sure. Let's see. Oh, they give us a formula. Formula, literal equation, really the same kind of thing. The formula for the surface area, S, okay, so S refers to the surface area of a rectangular prism, is S, surface area, equals 2LW plus 2LH plus 2WH. Solve the formula for length W. Okay, so all they're really giving us is they're giving us that whole explanation of what this is, but it doesn't really matter what this is. All we know is we have to solve for L. Okay, so we want to isolate this L. And these two have the L in it, but this one doesn't. So I'm going to subtract this out from both sides. So I have S equals minus 2WH is equal to 2LW plus 2LH. Okay, and then I'm going to factor out the L. I'm going to call it factor out. We're going to do that reverse distributive property thing again over here. So I can say this is L times 2W plus 2H. Now, technically, I could factor the 2 out too, but I don't really need to do that here. And so I've rewritten this side, so I'm going to bring this side down. Okay. And now, to get to L by itself, I'm going to divide both sides by the 2W plus 2H. Because over here, these will cancel, leaving me L on the right, and I want it by itself, which is what I have. So S minus 2WH all over 2W plus 2H. Okay? Okay, so, oops, let me make sure I put a box around this so you know this is my answer. Okay, let's see. Another example here. You own a rectangular lot that is 500 feet deep. It has an area of 100,000 square feet. To pay for a new water system, you are assessed $5.50 per foot of lot frontage. Find the frontage of your lot. Okay. So frontage is referring to the amount of your lot that is kind of like along the street or the sidewalk. Okay, so this has an area 100,000 square feet, and it's 500 feet deep. And to pay for a new water system, you are assessed at $5.50 per foot of lot frontage. So this is your frontage here, because this is where the road goes. So we're going to call this F. We'll call this F. Okay, so because the road is, this is kind of like where the road is. So how you're assessed at how much of your property is along the road. Essentially, that's the frontage. Okay, so find the frontage of your lot. So I know that that the area equals what? Length times width. But in this case, I'm using F. So area, I'm going to use, say, 100,000 equals 500 times F. Actually, let me back up. Let me kind of rewrite this formula in the way that they're doing it here. So length times, I'm going to change this to W. Okay, W. Okay, so I'm solving for W. So to solve for W here, I'm going to divide both sides by L. And then here's my new formula. A divided by L equals width. Okay, so essentially in this case, I'm writing a formula first specifically for this instead of just plugging into another formula and solving for those numbers. Okay, so I have 100,000 divided by length, which is 500. Area divided by length equals W. So 100,000 divided by 500 200. And of course, that's going to be feet. And that's the first answer. And how much are you assessed for the new water system? Well, if it's if the assessment is $5.50 per foot, then it's $5.50 times 200 And that comes up to, oh, I did that wrong on my thing. 5.5 feet, sorry, $5.5 times 200 feet, $1,100. Sorry, $1,100. That's dollars. This is feet. And that's 550 per foot. That's how our measurements look. Okay, that's that question. We're solving these formulas for indicated variables here. These require a couple steps. Area of a triangle. A equals 1/2 base times height. Solve for h. Okay, so I got to get rid of the 1/2. When you have a fraction and you want to do the opposite, multiply by the reciprocal. So the first thing I need to do here is multiply both sides by 2, because 1/2 times 2 is 1. So I have 2a equals b times h. And now to solve for h, I divide both sides by b. So these will cancel, leave me h on the right and 2a divided by b on the left. And there's my formula for the height of a triangle given the area and the base. Surface area of a cone. The surface area of a cone equals pi r squared plus pi r l. Let me make sure I did that one right. Yeah, pi r squared. This one came out wrong, so it's pi r squared, pi r w. I'm solving for L. So in this case, I have to divide both. I have to subtract pi r squared from both sides. Oops, subtract. And then to pi r, remember this is all multiplying, so I divide both sides by pi r here. So these cancel. Length on the right, then I have surface area minus pi r squared divided by pi times r. That's that one. So I've always said that this is the skill. If you can do this, algebra is going to be fine for you. If you can't get past the idea of manipulating general things that don't have numbers, generalizations, represented by variables, then algebra is going to be tough for you. But at this point, this is what you should be able to do. Don't worry. Well, let's get these formulas in our notes. Temperature, Celsius. This is a temperature to Fahrenheit. This is Celsius compared to Fahrenheit. This is interest, principal, rate, and time. And we know this one, we're getting distance equals rate times time. Get those in your notes because we're going to do one more problem here. Solve the temperature formula for F. Okay, so here's our temperature formula. Okay, so there's our temperature formula. And what do we say about clearing a fraction? We multiply by its reciprocal. So I'm going to multiply both sides here by 9/5. So 5 and 5 cancel, 9 cancel. So I have 9/5 C equals F minus 32. And now what do I have to do? Add 32 to both sides. Remember, I'm trying to isolate the F. So I get 9/5 C times C plus 32 is equal to F. And that is my rewritten formula for Fahrenheit. It was in centigrade, now it's in Fahrenheit. And that's it for now. I know this went a little bit longer than the other ones, but I tell you, this is a tough one. I'll see you in class next time. Bye-bye. Bye.